All right, example 6 is more equation solving. So 2 sine squared of x over 2 plus cosine of x equals 1 plus sine of x. So I see this. This comes from here, okay? Now this is plain old sine, and this is sine squared. So what I'm gonna have is, now because I'm gonna square this, it doesn't matter if this is positive or negative. Because the squared and the square root are gonna cancel. So I'm left with 2 times 1 minus the cosine of x over 2. The 2's cancel. And then a negative cosine and a positive cosine, those cancel. The 1's subtract from both sides, those cancel. And I'm left with 0 equals the sine of x. And so where is the sine 0? The sine is 0 at 0 and at pi. All right, so I see that these have two terms, and I see that they both have the tangent of x over 2 and an 8 in common. So I'm going to pull that out. And there's multiple ways of doing this. This is just one way. All right, tangent of x over 2. I have 3 choices, okay? I'm going to choose to use this one because, now I would go towards this, but look at what happens. This is a 1 plus cosine of x. Look what's on the bottom, 1 plus cosine of x. So if I choose to use that, I have, this still is 8's hanging out here. The tangent of x over 2 gets replaced by the sine of x over 1 plus the cosine of x. And so those cancel. So I have 8 sine of x equals 1. Divide by 8. Is the sine of x equal to 1/8 one of the ones that we are supposed to know? No, that's not an ace answer. So this is where it gets tricky, okay? So I have x equals the inverse sine of 1/8. And now we have to use a calculator. So I have to make sure that I am in degree mode, and I do the inverse sine of 1/8, and I get 7.2 degrees. This is only in quadrant 1, and sine is also positive in quadrant 2. So my reference angle is 7.2. 180 minus 7.2 is going to give me 172.8 degrees. Now, this is the answer that they have in the back of the book. The directions said to find the solutions on the interval from 0 to 2 pi. I'm not going to expect you to find these in radians. There is no problem in your homework where you're going to have to find these in radians, okay? Anytime that you have to find something in radians, it's going to be a nice answer. This is a not good example of finding the exact answers.